There's really a lot of facts you need to come into memory, and hopefully understanding concerning the exponential function. So again, the basic look of an exponential function, and again, we're going to drill this again and again, is just this. It has a y-intercept of, again, if I want to find the y-intercept, all I need to do is enter at 0, because that's the definition of a y-intercept. And look at beta 0th power, and that just equals to 1. So we have that the y-intercept is 0, 1 for this very particular look. And again, it is a 1-to-1 function. And again, because exponential function is important to mathematical modeling, a second basic look is, so again, if you could keep writing this over and over again, that would be fantastic until it just is normal. A b to the x, which I hope you see, it is a what? Well, a transformation of f of x equals b to the x. I guess I should call these something else. We're going to call this g, just to say something, make it look different. But it's just transformation b of x. How? By, depending on what the value of a is, by compressing stretching vertically, and potentially even flipping, if depending on by a factor of a, which again could, if could and can include a flip if it's negative. Right. The y-intercept of this function is, again, if I just enter g of 0, example, then what I get is a to the b to the 0th power. B to the 0th power is 1, so I get a. So that results in a y-intercept of, enter 0, you get a back out. Okay. Now, each basic look have a horizontal asymptote at y equals 0. So now let's kind of go back and take a look at this. So actually, let me define this. A function has a horizontal asymptote at y equals a. Again, a is a constant. If f of x gets as close as we want to y equals a, as x gets infinitely big, again, and we write something like as x approaches infinity or gets infinitely small, which would be the exact opposite, negative infinity. The use of arrows in mathematics are used not to say go here, but as a phrase of, as in this case, I'm going to write what this meant as, well, in this case, I'm going to just say generally a variable, as a variable approaches. So it says x approaches infinity. Okay. So now, what is a horizontal asymptote? Again, if you go back to these pictures, you'll notice that all of a sudden, we're not going to cross this x-axis. No matter how much we want to, we can't. So right here in this picture, we really should dot it, or at least to emphasize, I guess. I mean, we did this for, ask you to do this as students, just to remember that's what that represents. There's a dotted line here, and there's a horizontal asymptote at y equals 0. So can you cross the horizontal asymptote? The answer is yes, but can you cross for these exponentials? The answer is no. No, these exponentials will not cross this, okay? Now, if you transform them, of course, all we're doing is shifting. So of course, this can't change if we transform. But I'm saying this basic look that we have, notice this one. Notice the A here in front is a 1. The A in front here is a 1, right? That's the base. The a is just sitting here, but it's a 1, that's why it's missing. That's what it's going to look like. Okay. The rest of it is just transformation of that basic one. So no matter how close, if I entered, for example, 1,000 here, well, I mean, you can see that if it's out, it's going to be very close to 0, right? So G of 1,000 would mean that I take this and raise it to 1,000 power. So it's 2 raised to 1,000 powers. So this is, very close to 0, but it's not 0. It just can get closer. So the higher I go here, the closer it will get to, the closer it will get to 0. So I go G of 1,000, I get very close to 0 because I'm raising this to, again, the more, if you multiply a number less than 1 many times, you get closer and closer to 0. It's getting smaller. And likewise here, if I keep going to negative infinity for this other one, it just gets getting smaller and smaller for the same reason, just a backward phase. So there's so this graph is 2 to the x, while this other one here is g of x equals 1/2 of x. Again, I need the parentheses around to raise it to a power. Okay, so those parentheses are not optional, because if I'm raising it to a power and I wanted to apply to both the numerator and the denominator, I need parentheses to indicate that A applies to both. So an exponential function is always increasing or always decreasing. Again, this only applies to the basic ones. If the base is between 0 and 1, the function f of x equal b of x, again, this is very basic look, not a transform look, then f of x is decreasing. As we saw in the other example, the second example, if the base b is greater than 0, the function f of x, again, this basic one, is increasing. And again, you can see that from the pictures. Here is f of x equals 2 to the x, and you can see that it's always increasing. While this other one, between 0 and 1, it's always decreasing. Right. So let's look at these few examples. Is 3, f of x equals 3 times pi to the x, increasing or decreasing? Well, what did I notice? The base is pi, and I know what pi is. Pi is about 3.14, blah, 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 blah. So is greater than 1. So it is increasing. How about this one? Again, is this increasing or decreasing? Again, I know what I noticed, the base. 2/3 is between, I'm just going first, oh yeah, between, okay. Between 0 and 1, so it is decreasing. Right. If f of x equals 2/5 raised to the negative x, increasing or decreasing, again, this is a little trickier one, because I need to declare what is the base. So the base, notice, the basic look is this, x raised to a power. It doesn't have this, there's no negative, there's not 2x, nothing. This is the basic look. So right now I have this negative here, so the base really, that the negative is going to get attached. So what I'm going to do, get over here, do it this way. So in my mind, I have to think of it, again, using exponential rules as this. I break up the opposite of, and the x, I'll call the opposite of -1 to make my life much easier. Again, this is like rule that I said that this are two very different things, two different meanings, but they both result in the same output. So when we say they're equal, I'm not saying these are equivalent expressions or not, but the result of these two different expressions is the same. So now, looking at this and looking at the way I write this expression, the b is just this entire thing. So then the b is this part, not the x, this. So what is the base? The base is 2/5 raised to -1, which is, again, flip it, 5/2, which is greater than 1. So it is increasing. How about this one right here? Is this increasing or decreasing? So a lot of things going on here. So again, I'm going to break this one down to two parts. Just like I did before, I'm going to separate the exponent. So now I see that the base is, sorry, I'm writing the answer. So again, 1/7 raised to the -1 power is 7. So, and I'm going to rewrite this a little bit. I'm going to say h of x equal 1/7. Notice I didn't, I'm very clearly not including that -5 for a good reason. So, and I rewrote the functions so we know that this is a different thing I'm talking to. So this particular function is increasing, okay? Why? Because the base is greater than 1. Okay, but that's this one. I'm dealing with f of x. Now I have to take into account this negative. What is that -5 going to do? Well, remember, I'm multiplying now, and it's after the function. The function itself is raising something to a power. That's what the function does. But now I'm multiplying by -5. It's after the function. So if this was the function, then what I've done now is this. I'm going -5 times h of x, and now this is f of x right here. So what does this do? Well, one thing it does is it stretches it by a factor of 5 vertically, but this negative flips it across the x-axis. Wait a minute, flips it across the axis. So notice, I'm not going to graph this one exactly. I'm just going to graph the basic look. So what happens here is, here's h of x, something. H of x just looks something like that, as we saw. Great. But what happens when I apply -5x of x? Well, it's now all is being stretched and flipped across the x-axis, so all the y's become negative. So now what I have is this, stretched. So you can see that this is decreasing. So now I'm applying transformations. So is this function increasing or decreasing? It is decreasing. So f of x is a decreasing function. So what have I done? I applied the base rule first, then I to the basic function, then I look at what's happening and apply any transformation that is required. So really, what we've done here is dealt with a function of this type. We're now multiplying by some constant a. And again, it's a compressing or a stretching vertically by a factor of a and can include a flip across the x-axis. So keep all that in mind, and you're going to be set.